In this video, we will talk about how we account for the time value of money. We said in the very first video that the key ingredients to a price were current cash profits, the growth of those profits over time, and risk and the timing of those cash flows. So how do we account for the time value of money? But differently, how can I add cash flows that happen 10 years from now with cash flows that happen today? So why do we say the present value of money? Again, this is because cash flows that are produced today are worth more than cash flow that happens 10 years from now. And we now need to find a way of converting time 10 or cash flows happening in year 10 into cash flows today. So let's start with a very simple example that should sound very familiar. Let's imagine that you have $100 that you put into a bank account, and the interest rate for that bank account is 10%. Now, if you leave these $100 in that bank account for a year, of course, I'm referring to this interest rate as 10%. What I mean is you will earn 10% in that bank account if you leave $100 for that period of time. So $100 in the bank at an interest rate of 10% will grow to 100 times 1 plus 10%, or $110 after the year. Okay? So this should feel like a very familiar setting where you're thinking about how money grows over time if you were to use a bank account or many other financial instruments. Now let's take that as our baseline example, and then let's think about what is happening then if I flip this problem around. Let's imagine that instead I tell you that you will have $110 in your bank account in 1 year, and that the interest rate is 10%. And the question that I'm interested in here is, how much are those $110 worth today? So I am telling you the problem that I'm posing here is you have $110 in the bank in 1 year from now. The interest rate is 10%. How much is that bank account worth today? Now, of course, given what we did before, where we said that $100 grows to $110 after a year, it is natural to say that $110 1 year from now are worth $100 today. And so instead of multiplying by 1 plus 10%, as I did before, when I was taking money today and converting it into money in the future, if I'm taking money in the future and converting it into money today, I have to divide by 1 plus 10%. Now, the other thing that is worth recognizing is, again, let's take the $100 in the bank at an interest rate of 10%. That grows to $110 after 1 year. What happens after 2 years, or 3 years, or 4 years? Well, of course, that amount is going to keep growing, and it will keep growing at 10% each year. And so, again, suppose you start with $100 in the bank, your interest rate is 10%. After 2 years, those 100 will be multiplied once by 1 plus 10%, and they will be multiplied again by 1 plus 10%, for a total of $121, which is just 100 times 1 plus 10% squared. If you want to do the present value instead, then we again just flip things around. So we're now in a position of thinking more generally about how to convert cash flow in the future into cash flows today. And in particular, that formula is given by the following. The present value of any future amount of cash is given by that amount that happens in 3, 5, 10 years, divided by 1 plus the discount rate, which in my previous example was 10%, raised to the power of t, where t is the time in years that it takes between now and the time at which those cash flows will happen. Okay? So in our previous example, $100 is the present value of what? Of 110, that was the future value, divided by 1 plus 10%. That was our discount rate. In that case, raised to the power of 1. Or equivalently, $100 are the present value of 121 divided by 1 plus 10% squared. And we will have to say more about how to obtain these discount rates, but this fundamental formula allows you to transform money that happens in the future into money today. And you see that it follows this basic principle that cash in the future is worth less than cash today, because if I have those $121 in 2 years, once I convert them into cash today, they are worth just $100. Note also that if I now have cash occurring at different points in time, I can take each one individually, convert them into dollars today, and now I can add them up. I would not be able to add up dollars in 3 years with dollars in 7 years. But once I have converted both into dollars today, now I can add everything up. Everything is in the same units. Everything is as of money today. And that is what is being shown in this very simple diagram. Suppose you have a company that produces cash flow 1 in year 1, cash flow 2 in year 2, cash flow 6 in year 6, cash flow 7 in year 7, and so on. How would I add all of those up? Well, we just said, I can take each one of these, convert each one into dollars today, and now they are all in the same unit. They are all as of times $0. And so the present value of the sum of all of those just takes each one of those cash flows and discounts each one individually the appropriate amount of times. So the first cash flow will be discounted once. And you see in my example here, the sixth cash flow will be discounted 6 years. The cash flow in year 7 will be discounted 7 years. The cash flow in year 8 will be discounted 8 years, and so on. There is an important special case that I will return to in quite a bit of detail when we talk about the Che Guevara case. And that is, there will be instances where we will want cash flows to be growing at some constant growth rate G. So let's return to my previous slide. And now imagine that cash flow 2 is just cash flow 1 with some growth. And cash flow 3 is just cash flow 2 with that same growth rate. And cash flow 4 is the same as cash flow 3 plus that same growth rate. So everything is growing at some constant growth rate. So what this means is cash flow 2 will be 1 plus the growth rate times cash flow 1. Cash flow 3 will be 1 plus that growth rate that you've chosen times cash flow 2. But you see that that is just 1 plus the growth rate squared. So that's compounding 2 times the first cash flow you started with. And this will keep going so that cash flow 6 will be 1 plus the growth rate to the power of 5 times cash flow 1. Now, this turns out to be a very important special case of a sequence of cash flows, and I will explain in a lot of detail why that is. But there is a formula for the sum of all of these cash flows that are growing at a constant rate. And so just like we had here where the present value was the sum of all of the cash flows, each one discounted the appropriate amount of times, this formula is still true, but if you happen to have a series of cash flows growing at a constant growth rate, the sum of all of those simplifies to cash flow 1 divided by the discount rate minus that constant growth rate that you're using. Again, the growth rate is about the growth of the cash flows. The discount rate is there in order to convert future cash flows into the present.